Okay, as promised, this is the hopefully the fourth and hopefully the last video. This is another example of dynamic programming, and it is of about making an investment for a project, right? So I have several options available to me, and I want to find out what's the optimal or what is an optimal solution to this. So let's say I want to maximize hydroelectric power produced by building dams on 3 different river basins. My budget is $3 million. And my returns are, if I invest $1 million in the first dam, I receive $2 million in benefits. If I invest $2 million in dam 1, I receive $4 million. And for $3 million investment in dam 1, I get $6 million return. So I can actually figure this out, the benefits in terms of, the output. So each dam can represent a stage I, or an item on the list. That would be a column, right? The returns on investment are given in a table I'm going to show you here. So the investment levels are the X's. Right? The stages are the I's, and the investment levels are the X's. And the returns on investment at each investment level for any of these choices is given in the table here. Okay? So the maximum investment is $3 million. Can't exceed that. So the capacity, really, if you want to think about it that way, is 3. So I can set this up in this way, right? I can set this up as a grid, just like I did the highways. So I'm starting. This is my start node. Here I am, 0, 0, 0, 0. Okay? And node B is the first item, or the first stage, or the first dam, right? And the amount allocated is along the rows, X's. So the idea here is that if I invest in node 1, if I invest nothing, then I don't get any return. If I invest $1 million in node 1, or stage 1, I get a return of $2 million. See this? Right, so I'm in stage 1, that's the first dam, and I'm investing $1 million. I get a return of $2 million. That's where that comes from. Similarly, if I invest $2 million in dam 1, I get a return of $4 million, and so on. $3 million in dam 1, I get $6 million return. So I can fill out these links. Think of these, in the travel time case, it was travel time, right? That was associated with each link. The computer scientists call these edges. These are nodes and these are edges. I don't know why they call them that, but so these are links and nodes. Okay, and here's the decision tree, and each link has a benefit associated with it. So let's take a look at this one. So if I invest $1 million in dam 2, so I'm investing $1 million because I'm going from x equals 0 to x equals 1, see? Right? So I get 1 million in return. So I'm investing 1 and I'm getting 1 in return. That's this one. If I invest $2 million in stage 2 or dam 2, I get a return of 5. See, I'm going from x equals 0 to x equals 2. So I get a return, and I'm in this stage, I get a return of 5 million. If I invest 3 in stage 2, in DAM2, I get a return of 6. And the same, you know, I can, if I go from, if I invested 1 in 1, and I invest 1 in 2, so I'm only investing 1 additional in 2, so that's a 1. 1 additional, that's a 1, you see? Okay. So the idea here is to go from the beginning to the end, open nodes, and connect to all nodes that are, you know, connected to the current node. Record the cumulative returns. In the case of travel time, that was the accumulated travel time, and the best one was the least. In this case, the best one is the most because it's the return on investment. Close the previous node, choose the open node closest in time. Well, that's not the case. Choose the node that it has the highest return, I should have said here, and then repeat the steps. I just copied and pasted the previous algorithm. They are the same, basically. Okay, so let's record cumulative return on investment here in this tree. So cumulative return is 0. Here it's a 2, right? I've only accumulated 2. That's from this one. I have accumulated 4 and 6. So I can close node A, and now I have to travel from each of these. So I'm going to travel from here, I think, next. So if I come from B over, so if I come from stage 1, don't invest anything in stage 2, I still have a 0. If I invest 1 in stage 2 and have invested nothing in stage 1, I add 1 to the value, right? And 5 to the value, and 6 to the value, because this is the return on the investment if I invest 3 in stage 2. And I'm coming from node B. So I can cross that off. And now I can travel from node C. So I had 2, and I didn't invest any more, so I don't get any more return. It's just 2. I had 2 here, and if I come down here, I add 1, right? That's the return on the investment by giving $1 million of investment to stage 2. Okay, so that results in 3 total coming from this route. And this way, if I invest $2 million in stage 2, I get a return on my investment of 5, plus what I had already is 7. So I can close off node C now. And similarly, now here, by the way, I'm all done with this one, right? I can't come from D over to here because I can't go backwards. I can't take money back. Right? So my best route right here to this node is C, is through C. So I'm going to cross those things off. Now, coming from D, I've already come from C here. If I come from D, I get 0 extra plus what I had 4. But I get 5 down here. I add 1 to 4. I can close that off. And similarly, I'll travel from, I can see this is the best investment here. This is the best path. And then down here, I'll come from, what am I doing here? There we go. I crossed out the non-optimal paths. And then down here, I'm traveling from E to I. And there's nothing added, so I get 6. So the best one is 7. Best return right now is 7 coming from C. So here are my best choices, and now I can continue this. I'm not going to do it in much detail, but just a little bit. So if I come from G, I'll add 2 plus 0 is 2. because I didn't invest anything, no return. From G, with investing 1 in 3, I get an extra 3. 3 plus 2 is 5. If I come from H, no investment in 3, so I get a 5 plus 0. And if I come from H down here, and if I invest $1 million in stage 3, I get 3 back. So 3 plus 5 is 8. And it turns out that's the best choice. I kind of shortened it up a little bit, but you get the idea, hopefully. So the best path is this one. This is an optimal path through that tree. So what this says is the best investment strategy would be not to use plant 1 at all, to invest $2 million in plant 2 and $1 million in plant 3, and that would give me a return on my investment of $8 million. Okay. Oops, I didn't update that. Don't even look at that. Okay, that's it.